Thanks for showing up. My talk is called Controlling Tons of the Different IoT Devices with Swift. I've brought one device today because, as you see of the emojis, it's kind of hard to bring all other stuff we're making. And it's still in beta, but as the other speaker talked about earlier, we brought one device that works. We're working on a lot of more in the pipeline, but now we have one thing that works. And that's thanks to the last speaker, Florian, because his Mac is now powering the wired internet on our gateway. So that's really experimental. So just give him an applause for helping me. Okay, so I'm Håkon Bogen. I'm CTO at Beining Bogen. I'm mostly an iOS developer. I've been developing iOS apps for about 8 years. I also teach iOS development and at Høgskolen Kristiania, formerly Westerdals, formerly NITH. So I've been there all those three name changes. And today I'm gonna do my whole talk in playgrounds. So I'll just start with a quick poll. Does anyone here see the penguin on screen? Can you just get hands? Okay, that means my playgrounds are still working. That's really cool. So it still compiles, and I appreciate any sympathy applauses if we have an infinite beach ball or force quits of Mac. So when I run through the talk like earlier days, there has been at least one force quit every time, so it's kind of experimental. But hey, we see the print of Hello Penguin World, so we're doing good for now. Okay, so playgrounds. Sometimes it's just amazing. It's so sweet. When they introduced it, I was like, oh my god, this is really cool. How you can just do so much cool stuff with it. Show live demo, write code live, and it just compiles or whenever you change anything. It's really cool. But it can also be a real pain. It's horrible. Earlier, now it's more stable, but it's been a lot of pain to do it. I've seen like people do playground-driven development earlier, but it's been a pain to get it to work. And of course, there's still a lot of bugs. It has become better. So emojis in markup, just a pretty straightforward thing. Like Swift had support for emojis when it released. But that crashed like 25 times when I was building this presentation. And I used some emojis because this is like a playground and they have support for it. So one thing is I've found with playgrounds is that there are some weird workarounds that you just have to know. They're not documented. So usually when I write emojis on my Mac, I use this emoji picker like emoji and symbols here. Don't do that. It crashes Xcode every time. So if you want emojis in your playground, you have to, for example, send emojis to your girlfriend and copy them out from the message and just into the playground. That works 100% of the time. So that's a lot of the problems with playgrounds is that there are some weird issues that have some weird fixes. And here's just a couple of weird errors I have gotten while doing like this talk and just using playgrounds in our project. And I love this the LLDBRCD error because that has two forms. So it has one modal form if it's really bad, and it's just one like on the top, which I get almost every time I'm in a playground. If you get that, it still works. And there's like some command compile Swift failed with a non-zero code. I don't know, I have no clue what that means. And I'm old enough to have been working with Objective-C, and like in Objective-C days, we never had issues which didn't have a concrete solution. Like you had a syntax error. In Swift, you have like the compilers has a non-zero code. What does that mean? Like just clean or something? So for you guys, I'm going to give you some tips on how to get playgrounds to play with you based on my experience, just trying to use it. So of course, playgrounds is good if you just have a playground and you can write like just int stuff and do strings or test small functions. But they are actually useful when you can have them in your projects. So then you can use your code in the project. You can do whatever you want, which you are doing in the rest of the project. And for that, the rest of your code needs to be a framework. So here's I have a couple of imports. I import the SDK, which is the project we're in now. This is the SDK for our IoT app. So I've just committed the whole program into that SDK. So and that works. And we have imported reactive Swift and the date tool Swift. So of course we want pods as well in playgrounds because I want to test, be able to do reactive Swift stuff and maybe date stuff because dates are hard. So I always want to test live date stuff. So that's like the prerequisite. And in my research on when doing classes and teaching, Playgrounds works about 80% of the time, and I have some fixes for that. So one fix is my mic still working? Yeah, okay. So one thing is sometimes you have to just build your frameworks separately, like just selecting it here. If you have multiple frameworks, you have to just select them, build, select another framework, and build it manually. And that sometimes works. It can fix some of the weird issues, and that's not documented anywhere. Of course, if you should build one of them and the other is a prerequisite for it, it should work, but it doesn't always. So if you're having problems, just try to select the framework and build it. Another thing is my old enemy, SourceKit. A thing that fixes a lot of issues is just going to a code file. Now you see it just got colored. It's white and it gets the color. Then you know that SourceKit has identified the code. By the way, we can just change to actual developer theme now, so it's easier to look at code. So yeah, SourceKit is yeah, I think maybe that's the reason for some of the issues with playgrounds. So just opening a code file works miracles sometimes. Of course, the old clean derived data, delete derived data or clean the project, always a good idea. And I have a print statement because I'm not always sure if my playground actually run, because sometimes it's like stuff on the side. You see my luck thing. I don't know if that actually run or it's an old print statement or something. So I just print a random number. So I see if the random number changed. It actually has run and compiled from the last time I was doing anything. So that's just a small useful thing. And of course you can, if you're doing complex code, for example, protocols or generics, those are a little bit harder for the playground, in my opinion. So you can just comment those out and reintroduce it after the playground has run one time. One thing I also have found is that like working is kind of contagious. So if you open another playground that works, it might cause the playground you are in to work as well. So just have a working playground all the time. So in these projects I have a blank playground, which doesn't have too much. I have a print statement that says lol, and that works. So it can be contagious to the other playgrounds. And if still doesn't work for you, I would advise to check out next Xcode version. Because it's always better. And in my opinion, like now in Xcode 10, it's really stable, and it's stable enough for you guys to use it. And if you don't know if you should, let me show what we're doing with playgrounds, and maybe you want to try it. So can I just ask you guys, how many are using playgrounds like weekly here? Yeah, there are some people. Yeah, cool. So this talk is about controlling IoT devices. One thing we need to do that is, like, of course, having a great SDK for the control of the IoT devices. It's a lot of different devices. They need to be controlled in different ways. And of course, every web-based app needs an SDK, and that's what we have here. And my first advice now in Xcode 10, not in earlier versions, but my primary advice is to have a playground, like playgrounds in the SDK, to be able to onboard new developers and as a place to experiment and test the actual SDK statements. So here's just some setup we need for later points. And for a SDK playground to actually be useful, you need to have a secrets file, so it can always work if you need to test anything. So I have a secrets file in this project that's auto-generated by an install script, which I've written in Swift, of course. It just runs like shell commands, but just copies a secrets.example thing, like a file, and it has everything you need. So, and that it can run on continuous integration servers, so it does compile there as well. And I've just thrown in pod install and git submodule update in there as well, just for good measures. So here I set up like the basic service in which our app use, with basic authentication and like username and stuff like that. So I don't need to check in the secret stuff. And you need to, we do separate the SDK completely out from the rest of the code base. So as you see now, we have just the project, which is just the SDK, and our main app is a completely different project. This project, it just imports the SDK as a development pod, so I can just live update it from there. It can of course be in the same GitHub repo. We don't do it, but maybe it doesn't need to be that separated, but you should always try to separate it as much as possible. And one thing, when you're actually like writing the SDK code, I love to like make it hard to make mistakes for people who use it. So it should be really obvious how to do stuff. So for example, we have for setting the hue of a given light bulb, it should be like set hue. And we have how we do the requests. It's kind of a little bit verbose, but we need a home ID. So we have like the secrets file, example home ID. We have the device, example device ID, and we have a hue value which we would set it to. So for example 100, and we have to call start. So now you see the bulb actually working. So the live demo worked. Phew. Thanks. So we can, of course, just, it's a playground, so we can just change the value, and it just changes the color of the bulb. And we can change it again. We could write more requests. I can just scroll a bit. We could just write service set saturation, for example. And that's secrets.example home ID. Example device ID, and the saturation value. So the saturation is kind of how white the bulb is. Now you see we got the LLDB RPC server thing up top. Doesn't matter, it still works. Now it got a little bit wider. So we can set it to completely white if we just set 1 as saturation. And while we're testing a lot of different bulbs from like I think this is Ostrom bulb, we're doing Hue, we're doing IKEA, a lot of different things. And it's really useful to have just, we get a new bulb on the office, open Playground, and you can just write to it immediately. You don't have to run your app, find the latest test flight version, do anything like that. It's really cool to just be able to do it in the Playground. And when you're doing SDK, one thing I think is really important is to have great logging. And what I mean by that is like the output that's written when you do a request. So if you can of course turn this on and off, but as you see here, for every request we do, we print out a curl commando to do that request. So you can just copy the curl commando here and just open terminal and write it here, and I've done a curl. So if I want to not use Playgrounds, maybe it's bugged, one day it's bugged, I can just get the curl commands and just copy it from my output, and now I'm doing it curl. It's that simple. And that's also really useful. Not always you want to do stuff with Playgrounds, and you want to do it in terminal. Maybe I want to add some different headers or something. And that's really useful. So all of our requests have the option to show the curl output for their request. And we also have a YAML format, which shows like the method post, the headers for the request, the body for the request, the response, which code, yeah, of course, you know, this kind of stuff, and the body. And that's really useful to always have, like, just lay the groundwork early. So you don't have to break into your running app to find out what the headers was, or what did you actually send. I've used so much time on that, like over the years, so I've just made like this. I always include this kind of stuff in my SDK methods. So another thing is to use model objects when you get the response. And what I mean by that is that we have, for example, we have a service.get homes, takes a requestable init. I'll show what that means later, and it gets a result. And the result has a value, and it has homes. So get homes, that returns an array of homes, not a dictionary, not JSON, which you have to decode in your recontroller. It just should, of course, return the objects. And we're using like the new decoding stuff with Swift 4.0, I think, just to handle this. And everything is done in the SDK, so no view controllers or the main app doesn't have to worry anything about how it's done and what keys are used and stuff like that. And when you're building an SDK, don't be afraid of refactoring. I have here are some examples which are still in our project, deprecated. And that's why I have a lot of warnings now, because I've recently added the deprecation thing. So we can just look at those. So for example, if I go to request type, we see that it's deprecated, and I want to use my requestable with the great logging and stuff like that instead. We have request type 2. That's like just a small improvement on the request type, which was the initial thing we did. I just managed to like get rid of one attribute, but I wanted to do more. So here is, for example, the API type that I removed. It has 5 cases, and I don't exactly remember, but I think I just did 5 requests and like thought maybe I don't need this. So why not refactor it? Because I think I can write this protocol so smart that it doesn't actually need that attribute. And if I scroll up here, like we have a lot of requests, so I haven't gotten time to refactor everything in the app and remove all the deprecated stuff. But I have experimented with associated types and protocols just to make different kinds of responses in my app. because how we control IoT devices is really different. We don't always care about what we get the response. We have to just ping the server later to learn if a bulb is turned on or off. And that is the needs message to complete. That means, for example. And what I wrote all these protocols to make like the ultimate request, I've managed to like finally get everything in one protocol, and that's what I call requestable. And that has everything a request needs. It has like a parameter path, which is path components providers, also protocol. You can set whatever you want as response, and that's defined in when you make the struct that follows the protocol. And we can see, for example, in the setHue requestable, it has no parameters. It's an action ID response, so that means it just gets an ID, which can be used to listen later in the feed from the gateway if it has completed. So it doesn't care actually about what the return value is, anything other than the action ID. It uses the standard API. It is a post method, and the path is created on this way. Like it's a homes/home ID /devices/device ID, and that's just the array of paths, and an optional query with if I need like question mark equals and augtine and stuff like that. So all requests in the app are just made this way. We can just look if we can find get homes. Get homes requestable. Yeah, get homes response. So here's the get homes, which actually cares about what kind of response it needs, because it wants to get homes. It wants to return an array of homes. So I've just defined a response for that, and that tells just have the rules for what kind of decoding it needs to get the homes out of the response. So here's like when a new developer comes in, he can just easily make a new request, because just follow the requestable protocol, and you have everything you need. You don't need to have any other things. Everything is here. Every rule to follow how we do requests. And like don't be afraid of refactoring, and I think always don't be afraid of asking stupid or basic questions. Like I just checked my Stack Overflow, and like the most upvoted thing I have is like how to return the first 5 objects of a Swift array, and that's like really easy. But yeah, like people appreciate the basic stuff on Stack Overflow. So don't be afraid of asking those kind of things. And in my opinion, when we were making an SDK, I like to do a lot of tests in our apps. So I like having it easy to be mocked. So our service is just like following a protocol which defines all the requests in the app. And it can be easily replaced with a mock service, where you can just send what kind of responses you want on a given request to the mock service. And we use that a lot when testing actual view models or view controllers in the app. But I think that's important to, when you lay the groundwork for an SDK, to be able to easily mock the entire SDK, because that's really useful when doing things that needs a lot of testing. So we're building IoT apps, and basically you can control everything with our app that talks over a protocol called Zigbee, and that's an open standard. So our app should be able to control a lot of different stuff, and we don't know what it will control in the future. We just know that in our roadmap we want to control bulbs and some basic stuff now, but in 2 years maybe we control your toaster, your UFO, or your toilet. And you don't really want 100 different apps to do that. In my opinion, it's best to be able to control everything as a group, when I leave the home, I want everything to turn off. I don't want to open my door lock app to lock the door, my Hue app to turn off the lights, my toilet app to turn off the toilet, and stuff like that. I want one app to control them all. And if you don't want to do like really advanced stuff, maybe I want a special app for that. But I want one app to be able to set up rules for everything. So let's look at one feature in the live app. And so here I'm just running the app for this room. We can just set the bulb to red, and it automatically goes to red. We can set the saturation, and it goes to white. It's a little bit laggy now because we're not on good Wi-Fi, but it should work for most of the time. I can also, if I close it, I can also use my app on my phone to control the bulb, and it should show in our app immediately that it works. Like you see now, it's a small spinner that shows up when it knows that it has been sent the command, and it changes when the actual color changes. So this happens pretty immediately. So we saw a little demo of this, and I have some rules for attributes of IoT devices. And one rule is that multiple sources can control the device at the same time. I can control it with my app. I can control it in my simulator. A person can actually stand and tap the switch on the door or on the wall, and that's a really that's a challenge. And in my app, I need it to stay up to date all the time. When you see it here, you don't want to show it red and it's actually another color. For example, if it's blue, or I want it to actually be updated all the time. And it should not update while I'm controlling it. So it needs to stay up to date all the time. But while I am actually dragging the slider, or if I'm dragging this and someone else changes the slider value, like the saturation, I don't want it to like lose track of where I'm dragging and update. So I don't want it to stay up to date while I'm controlling it. When I like release, I want it to update to the correct value, but not while I'm controlling it. So there's one exception to like staying up to date all the time. And like when you are controlling it, basically shows an out of sync value. And that might happen if I do stuff in my app which never got sent to the server or something like that. And it should not show those out of sync values for too long in the app. It can show them for a while it shows a spinner and just tells you that there's a pending action. But it shouldn't show them for too long or forever, because the user sees like if the lights are on in my place and the app says it's off, it's just wrong. So it's a lot of these rules we have for IoT devices, and this is just for color controlled bulbs. So there's like 5 different rules just for how to show what kind of status a bulb has. And that's kind of hard. So I just added like a playground here. Like I can actually stress test this bulb a little bit to test some of the things, like how will it look if we do like this request after 1 second, and this request after 5 seconds. We can change the hue value to 200. And we can change the saturation for 70. And it's really easy to have fun in playgrounds, because now it's just changing all the time, and I can easily test if my app is up to date with what it's doing. Now it's changing. I can just get it to compile once more. Just copy one more after 5 seconds. So these after closures. Oh, can I get an applause for a forced quit? Yeah, okay. First one. Yeah, we're good. Oh, it actually managed to copy. So I'm actually running an unsigned version of Xcode with plugins. So it's really should be unstable, but it works pretty well in that case, I think. So I can just change this to 1. So now I'm just changing it, and we can see if it stays up to date. We can see it in here that like the two color changes here. Maybe we can do one more. So just changing one line, it recompiles and it changes a lot of colors. So now it will probably, since the saturation is a little bit down, it will probably not show the true tone of the color there. But these are rules which we can do in playgrounds, but I want to have automated ways of doing this. And one problem with building IoT apps, maybe this is for your app as well, but it's loads of complex rules for just controlling basic stuff, like dragging a slider. That's pretty basic. Just tapping a color in an array or a collection view, that's pretty standard. My suggestion is to have like automated tests for all complex rules. So here I just made a little bit like a calculation. How many tests do we actually need? So we support maybe 40 devices. We have 5 of these complex rules per device, and we need probably 3 test cases per rule, and that's 600 tests. Okay, that's a lot, but then we are supporting 40 different things in our app, and that's that might be actually feasible. We have over 100 tests now. But one thing I've discussed with many different developers, and in my opinion, like vanilla iOS makes creating useful tests really hard. And to be honest, the example projects from Apple suck. Do you agree with that? So I teach, when I teach, I want my students to learn how to do stuff in iOS apps, right? And I tell them like, okay, you want to learn collection view, maybe you have done that in class, check out Apple's code. And then I think, oh no, if they do that, they will do bad on the exam because the projects suck. They are good for doing collection view, for example, the example collection view, but they haven't do any good architecture. No tests, no anything like empty test project, empty test target. In my opinion, we have like chosen an architecture for actually having useful tests. And I know a lot of different people use different architectures. But one thing I'm sure of is that it's really hard to get vanilla iOS to work with tests. So I'm happy to have discussions on what some people are doing with having useful tests. I'm not going to say that our way is the best way, but I know there's a lot of different architectures, and I've tried them all, at least these. But I'm happy to have discussions on having what kind of architecture fits what we're doing. But one thing I'm always having to justify when I'm discussing with other people about doing tests in apps is like I have to justify why I want tests. It's not other people having to justify they don't have tests. So it's like hard to discuss these things often. But what I look in having a great test base is that tests are documentation for these complex examples. Like we have a lot of rules just how to slide a value. And if you look in the tests, all these like cases are documented because we have tests for everyone. And if we want to change a little bit, like hardware changes all the time, we can have regression if we change something with the slider and it affected maybe the security door or something. It's easier to find regression when we have a lot of tests. And my favorite thing is when we onboard new developers, it's really easy to learn the code base if I just tell them, make tests for this bulb. We don't have enough tests for this bulb. Start by doing tests on it. Because then you have to learn everything. You have to check all the other complex rules and find a new complex rule which maybe you haven't tested. And that's, I've found a great way to learn a project. So I just want to show you some of our tests on the color control bulb. And this is just our way of doing it, and I would really appreciate if some feedback on this. So we're doing it with like reactive programming, and this is just a way of setting up like an object with a given attribute. So we have a device, and we set it that it has 100 saturation. So 100 saturation means that when I open it here, I send it to a view model, and I say we view did load. The slider should show 100. Like it shouldn't show 0 if you open this view model with 100 saturation. It should show, of course, 100, and that's really basic, a really basic test case. So one other test is that it should not update the slider. Like this is kind of hard to say. Do not update slider with same value more than once. So since we're streaming this data, like the device has 100 saturation. That's a signal we get all the time. It's sent from the backend a lot of times, and we want to assert that it's never actually outputted to the slider more than once, because if it's outputted more than once, it just wastes CPU cycles. So this is just a test for the view model. We get a lot of the same signal, which is device has color saturation 100, and the backend sends those pretty often because someone else is controlling something in the same room or something, and it's just sending the same value. So we have tests that we don't want this to actually output more than once. If it changes, of course we want it to output, but not the same value more than once. And another complex scenario I was talking about is we don't want to actually update the saturation while we're dragging, because that's that was quickly a thing that's really annoying. If you like drag something and you just lose control of the slider, that's really painful to watch, and it should be a priority to fix. So we just create the device with 100 saturation. We load it into the view model, and we say that the slider control event should be began and moved. So we're dragging it, and then the server sends that the device actually has color saturation 80. But we don't want the slider to move to 80, because while we are dragging it, we don't want it to move. So here's just a test for that. And here's a test where we actually use the mock SDK. We want to do a saturation request when you have ended dragging. So you're dragging the slider, and you want to do a saturation sent request, like you want to actually send the value to the server so that it actually gets updated. So here we're dragging a bit, and we send ended, and we send that we want to do a set saturation request, and we load that into the mock service that's currently running, and we assert that a request actually was sent. So here we might, like if I have any junior developers joining the team, maybe we should see that, maybe we should assert that it only sent one request and not two, because this actually just sees that the assert is that last performed request is not nil. So here I just see a error in the test. And here's like the final test I'm going to talk about now, and it's also a complex one. I'm seeing that the name of the tests here are getting a little bit hard to actually read, because maybe we need another way of documenting what the tests do. So this is test update after getting correct value from server after ending drag. So what that means is after I ended dragging, I wanted to update if I get another value from the server. So I drag it to 80, 20, and another person just sets it to 100. Then I want my slider to actually show what the last person sent, and not me, even though I actually just ended the dragging. So I drag here to 70, and I get a 20 value from the server, and I assert that the slider should get that value. So I can just go on and on with the different tests, like here's the hide slider, show slider, but I'm gonna just leave it at that for now. So now I've just shown you a couple of our tests for really basic stuff, and I want you to just ponder some questions after seeing my talk. Like, could playgrounds offer value in your projects? Maybe you see that it can have some value if you're doing a lot of networking requests, for example. It's really useful. What's important when you're building backend facing code? Do you separate it out? Do you have it obvious what the responses are? Do you have great logging? And could you somehow include tests in your development flow? So just think about those. I'm not going to like tell you you have to do it our way. I'm just showing what we do. And I think that playgrounds basically released in Xcode 10. That's the first time they have been really stable. I think those are ready for prime time. So on the end, I'm just going to give a shout out to someone, and that's you have to look at the Breaking into TVO's design and development talk here at Mobile Era. It's my colleague Eva who has it, together with Volume, and so check that out. And of course, we are hiring. If you want to work at a place like us, just don't be afraid to send a what's the like application. So if nothing crashed, it did. We have time for questions, but it crashed one time, so maybe not. I don't know.
I think we have time for a few questions.
Sure, we might have time for questions if anyone has one. Yeah.
Do you have a concrete example of the suckage of Apple vanilla iOS tests and what problems you were facing since you found your golden path or
So do I have an example of like Apple's testing that suck? Are they doing any testing in their example projects?
Yeah, but your statement is that in vanilla iOS testing sucks, so you need, or the way I interpreted you was that you need functional reactive programming or reactive scripting.
Yeah. Oh, yeah. Okay. So.
Some other way of doing so. Good testing is not possible in vanilla.
Yeah. That's.
How I interpret you. So I wanted if you had a concrete example on.
Yeah, basically I worked on iOS development for a lot of years, and I've never seen iOS like vanilla iOS have any great testing. Like, could you do that kind of testing where you're actually testing the outputs that actually are showing, and not like need to have UI tests or something together with it? If you have built a way of doing that, I would love to see it. But in my experience, I haven't seen easy testing in like how to do testing in vanilla iOS. But I would love to be proved wrong, because just having like a layer between is not always optimal. Yeah, you below.
I've maybe seen it once before, but the other thing was about the tests. So maybe it's not applicable, but we still build our SDKs in Objective-C, and this year we adopted Kiwi to write our tests, and it makes them so much more readable and much easier to reason about what you're testing and to find small bugs or inconsistencies in your logic. And I think although you have good structure, but in the tests, I think they're getting too long.
Yeah.
And especially the names of the tests are very unwieldy.
I definitely agree, yeah.
So one thing about Kiwi is that basically you have natural English for the names of your tests, and it's much easier to
Yeah.
parse it.
Wow, that sounds like we absolutely have to check out that.
I think Swift has kind of equivalents.
Yeah,
like
I think I
Quick
maybe
or
heard it, but
something, but yeah, other people might know more about that.
yeah, thanks for the feedback.
cool talk.
I would love to check that out. So, any more questions? Or is it time for next speaker, maybe?
Actually, it's almost time for lunch.
Almost time for lunch. Okay, yeah. Thanks.